All right, good morning, everyone. Luke Hoban here on this week's episode of Pulumi TV. This week, we're going to be talking about serverless with Pulumi. So for those of you who haven't joined us for any of our previous episodes, Pulumi is a cloud development platform that helps you get code to the cloud faster and together. And Pulumi is all about making it easier to bring the skills you have as a software developer to managing your infrastructure, including containers, serverless infrastructure, and the combination of all three. So today I want to really kind of deep dive into the serverless piece and take a look at kind of what it looks like to build a serverless application today and how Pulumi can help make that easier in a really fun way to get your serverless applications running. So first off, for those of you who haven't installed, I'm going to start with Pulumi. You can come to pulumi.io, download the command line installer, and go ahead and get the CLI. And today we'll be spending our time looking at code and running commands, and all of that you can get started with right away. So if I come up to Pulumi.io, one of the great ways, there's a lot of great ways to sort of learn about the various capabilities, but one of the great things I always find useful is just looking at a bunch of examples. So we have an examples repository which has many different kinds of examples of things that folks can do and have built with Pulumi. So I'm going to be using a couple of these today, but if you're interested in learning about other kinds of things you can do with Pulumi, whether it's using other clouds like using Azure or using GCP or Kubernetes, or whether it's about using other languages like Python or Go, or about using other libraries and other capabilities. All of that you can get in these examples repo right here. So I'm going to get started, just kind of talk a bit high level about why it is that sort of serverless is kind of interesting and why it is that Pulumi in particular plays a role there. So serverless sort of has become a very significant part of a lot of teams' way of thinking about how they want to deploy code. And I think it's driven by kind of three things that sort of, for me at least, define what serverless is all about. The first one is serverless platforms are consumption priced. So you pay only for what you actually use instead of renting some infrastructure for hours, weeks, days, months. You pay for only the amount that actually gets consumed, so the amount of traffic that actually goes through the HTTP endpoint or the amount of invocations of a function. And that can mean significantly lower prices depending on the utilization you would have had of that infrastructure. Serverless can be a much cheaper solution, but it also feels much more flexible. If I can optimize my solution to take less traffic, then that I can immediately see the returns on that, whereas I might not if I am renting some fixed amount of hardware. The second one is that obviously the sort of no serverless part, so there's no servers I have to manage. And that's sort of a really important piece in the terms of kind of raising the level of abstraction, and in part that's what sort of has attracted so many kind of application developers to serverless, is that they don't have to worry about sort of VMs and managing infrastructure and updating and patching their OS and that kind of things. They can just think about their application and then getting that running in the cloud platform. And then the last thing is sort of event-driven. So one of the key things that sort of happens, especially as you think about sort of consumption-priced workloads, is the pattern of the application kind of changes a bit. Instead of being just I have some code that's running all the time, it tends to be instead that I have an event-driven architecture where some set of things that happen inside my infrastructure or my application cause events to happen, and those cause functions to execute on demand. And that way of thinking lets me think about that consumption priced aspect in a much more raw way. And so these things together create sort of an opportunity to create new style of applications on top of serverless and to reduce costs by using serverless. And these are very attractive. One of the challenges I think that a lot of teams have when they come up to serverless, they really like the promise of it, but especially when those application development teams come up and say, hey, I've got some code, let me go and just run this inside AWS Lambda or in Google Cloud Functions. They run into the fact that it's actually a lot of, because they don't have to sort of manage the VM, they do instead have to manage lots of granular cloud resources to actually deploy that application. So they've got to use something like CloudFormation or Terraform or one of these sorts of tools to describe all the various different pieces of infrastructure that they need to get every single one of those functions and APIs and whatever they have running in the cloud platform. And so one of the sort of most significant things that serverless kind of has done is actually mean that development teams have to own a lot more infrastructure, which is sort of maybe counterintuitive, but has been one of the big shifts that's happened. And as a result, a lot of these teams are looking for tools to help them manage that at kind of a bit of a higher level and a bit more easily. And so there are some tools out there that do this sort of thing. I'm going to show kind of how Pulumi in particular fits in this space and provides a combination of a lot of flexibility to do anything you want with the infrastructure, but really some really beautiful ease of use around serverless patterns. And so with that, I'll just kind of start diving maybe into some code and show you what this looks like when we're using Pulumi. So let me come over here into Visual Studio Code. I'm going to show some of my code demos in here. And so this is that same examples repo that I showed you in GitHub. And again, we have many different examples. And the one I'm going to start with here is this AWS TS Serverless Raw. And this is an example of just what the bare bones way to use AWS infrastructure to build a serverless application looks like. And to give you a sense of kind of what Pulumi can do, Pulumi embeds the ability to sort of program cloud infrastructure into your favorite programming languages. So in this case, we're using TypeScript. We could use JavaScript, we could use Python, we could use Go. And here, I'm just sort of describing all the infrastructure that I want to exist inside my application that I'm deploying. And so I am using this Pulumi Aws Library, which gives me access to all of the different primitives in AWS. And so, for instance, I can create an AWS DynamoDB table, which is going to be my counters, describe that it has an ID and that it has a certain read and write capacity on it. Let me just open that up again. Okay, and then I can describe a variety of other resources that I have. So I can describe a policy document. I can describe a role. These are sort of identity and access control things for AWS. I can connect that role policy. I can connect that policy document to that role with a role policy attachment, and then I can create a function. Now all of these are just the raw building blocks of how, if I'm using AWS, I need to describe all the various different components that I want to put in, that I want to define in my cloud platform as part of deploying this. And so this might look similar to what, if you've done CloudFormation or Terraform or anything like that, these kind of resources are going to look similar. And at this level of abstraction, we're really kind of doing many of the same things we might do. What we're doing in this case is we're actually deploying an application that's written in this .NET application publish folder, which is in this location. And in this case, we actually have a little .NET core application. So just this 100 lines of code here. And this is just a little application that every time it gets an API request to it, it increments a counter and updates that inside a DynamoDB table. And so a very simple piece of logic that I'm just going to embed inside this application. But to do that, to get that piece of code running, I need to sort of describe all this infrastructure here. So I need to describe that I want a DynamoDB table. I need to describe that I want a Lambda function. I need to describe the role and policy associated with that Lambda function. And then I need to describe an API. And so AWS has API Gateway, which allows me to describe, which allows me to describe the resources I need. And so in this case, I'm going to create an API Gateway REST API, and then a deployment, and then a stage. And then I'm going to create the permission that gives that Lambda the ability to be invoked by API Gateway. And so there's a lot of complexity here in how I need to build this up. I need to describe this Swagger specification. I need to describe the overall body of the Swagger spec and what routes I want to include. And this is really, this is really sort of the bare bones that someone's going to have to do if they come up to serverless and want to get sort of a simple REST API running with AWS. Something on the order of this kind of code is sort of the bare bones ways that AWS provides to use these functionality. The problem is that if what I need to do to get an API running is to write all of this code, that's really a fair bit of work, and really the infrastructure side of that work way outpaces the application behavior of that piece of code. And so what we really want is a way to get all the flexibility to use all these powerful capabilities of the underlying platform, in this case of AWS API Gateway and of Lambda and of all the variety of other resources we're using here, but to do it in an easier way, and so to take some of these patterns and create nice reusable abstractions and libraries over them. And really this is where Pulumi can shine, because Pulumi, by using languages, lets me sort of refactor my code and create reusable abstractions on top of it. And so you see a couple of simple examples of that here, where, for example, to build up this Swagger specification, instead of me having to write it all as one big JSON document somewhere, I'm able to actually write code that constructs it. And so in this case, I have a function called Swagger spec, which can build up my Swagger specification. I have a Swagger route handler, which describes how to take a Lambda's ARN and embed it into a route to create the portion of a Swagger specification that describes that route. And these let me just give names to and factor my code in the ways I would want to, and not have to kind of fit that all into just one big declarative JSON or YAML specification. But we can go a lot further when we have a language, and we can actually take the ideas that we want to express, like I want to create a REST API with these routes, and we can turn that into its own reusable abstraction and give that a name, and then use that instead of having to use all these individual small building blocks like REST API and deployment and stage. And so let's take a look at one example of what that looks like. So instead of me writing all the code below, well, actually, before I do that, let me just run this and show you that we can what it looks like to kind of get this code itself into production. So here I am over in a terminal in that same folder, and I can run Pulumi stack ls. And stacks in Pulumi are instances of an application. And so in this case, I have one instance running. I'll actually just go ahead and destroy that so I can show you what it looks like to run this from scratch. Let me see what the... well, actually, what I'm going to do, I'm just going to create a new one so we can see that. And I'll say Pulumi TV... Okay, so with stacks, I can have an isolated instance of an application. And so I already have one running that I saw before, but instead I'm just going to create a new one here. And I'm going to go ahead and configure that. So I'm going to say Pulumi stack, Pulumi config set AWS region, and I'll say US West 2, because I'm out here in Seattle. And then I'm going to say Pulumi update. Let me actually... Since I'm using TypeScript, I'll actually go ahead and build that. And then I'll run Pulumi update. Now Pulumi update deploys my code into that running application. And so this will show me, here are the set of resources that I want to create as part of building that application. And if you look at these are really kind of one-to-one with the stuff I had in my code. There's that table, there's that function, and there's that REST API and the various pieces needed to deploy it. So Pulumi update starts by giving me a preview of what changes it's going to make to my cloud platform. In this case, it's going to create all those resources because this is the first time. I'm going to go ahead and say yes to run that update. Now you notice I'm getting these warnings here, and that's because I happen to be doing some development on my machine and have a dev build installed. For those of you who go ahead and download the binary that's available on Pulumi.io, you should not be seeing that warning yourself. Okay, so this will go ahead and actually create all of those resources. So we see it already created the table, it's now creating that function, and now it's going ahead and creating the REST API and the various other pieces. And so when it finishes, it then prints this output. So Pulumi has the notion of exports from your top-level program, which are outputs. And so in this case, I defined an endpoint output. And so I can go ahead and curl this endpoint here. And I'll just pass, hello. Oops. Takes just a second for the cold start the first time we run this function, especially since this one is implemented with .NET. I've noticed .NET's cold start time is just a little bit longer than other things. But so this one, what it will do is actually increment this counter every time I hit this endpoint. And if I go to a different endpoint, like if I correctly spell hello, we'll see we get a different count. So this went 1, 2, 3 here. So this is a very simple serverless application that's just counting how many times this given path has been hit. So I'll try Pulumi. Okay, and so that was running my application. And one of the nice things is, because I was able to describe all of my infrastructure that my application code should get delivered into that infrastructure in one program, I can do this thing where I just say Pulumi stack init, create a new stack, and then deploy it into that stack. And in about just under 30 seconds, I have a new instance of that whole application running, including all of its infrastructure, but also a deployment of its application code. So this is the sort of beginning point, and this shows that I can sort of use all the capabilities of AWS. And I could do that. I could bring in a Kinesis stream. I could bring in anything else that I want to from AWS into this program. But as we were talking about before, what I really want to do is kind of make some of this stuff simpler. And when we talk about how great Pulumi is for serverless, what we really are kind of talking about is the abstractions we've built to make it really simple to work with serverless applications in Pulumi. So we have a library, as well as the raw AWS library. We have a library called Pulumi AWS Serverless. And this is a set of helpers that let me work with serverless APIs. So let me take a look at kind of what some of these things are. So serverless has currently a handful of helpers to let me work with various different kinds of event sources that might exist for serverless functions in AWS. And so that's things like topics and queues, which I can handle events off of really simply. It's things like CloudWatch timers, like buckets, which I can handle when objects are put or deleted from that bucket. And then for our case right now, there's API Gateway, which is the ability to define an API whose routes are handled by lambdas. And so let me create one of these. So let me say const new API, and I'll just call this thing API. And then it has a bunch of arguments that I can provide. And so one of the nice things, of course, we're using TypeScript in this particular case. Because I'm using TypeScript, I can kind of get a bunch of developer help. So I can get IntelliSense and completion lists here. I can get error checking. So if I misspelled API Gateway, I get that feedback immediately. I got that help to actually explore the various capabilities of the library in here. So overall, kind of nice developer-friendly things that you get as soon as you embed this this kind of cloud API inside a real programming language, inside tools like Visual Studio Code here. So I'm going to do a couple things. So first, I have the stage name property which I used above, and that's going to be in this particular example. You saw that it was under the API stage. So I'm going to pick what name I want to use for that, and we'll see above I had a variable called stage name for API. And then I also want to define the routes. And so routes, we can also go and look at and see, hey, what is the shape of this thing? So it's an array of routes. Each one of those routes is a path, a method, and a handler. So let's go ahead and write that. So we're going to just have a single route. We're going to implement the same thing that we kind of had down here where the paths was just this. And so we're going to have, method is going to be any. We're going to accept any route on this thing. The path is going to be the same as down here. And then the handler is going to be this lambda. And so we have this lambda up above, the same one we created before, which runs that C# code. What we'll do here is we'll just pass it in to this handler here. And so what that does is this serverless.api.gateway.api really just takes everything that was in this code below and wraps it up into a simple-to-use API. And so in this case, now I can just say API dot, and I get a bunch of different variables that give me access to the implementation details of that thing, including I can just get the URL. And so let me just change it to that. Come back over here and say Npm Run Build. And now I'll do another Pulumi update. And so one of the things you'll notice is that we're actually changing our program in place here. And so we've already deployed an instance of that. What we're doing is we're updating that existing running instance. And so the first thing that Pulumi will do is tell me, hey, here's the preview of what's going to change. And we'll see kind of two things. One, we are deleting the existing REST API that we defined, and we're going to create a new one. We're going to create roughly the same set of things, but with some slightly different names because they're created by that separate component. The other nice thing is that because this is part of a new component, this API gateway : API, you'll see we're nested. And so all of the resources that are needed to build that particular part of my infrastructure are going to be nested in this view. And that lets me sort of understand how the different pieces of my application are related to one another. So I'll go ahead and say yes, and we'll make those updates. And so this will go ahead and create that new REST API, and then it will delete the old ones that are no longer being used. And so because of that, we now have a new endpoint that this is exposed at. So let me curl that. But even though we have a new API endpoint, note that we actually are still using the same DynamoDB instance. Because we allocated that previously and all the other changes we made didn't impact that, our application is still continuing to use that same DynamoDB instance. Now before I jump back into the code, let me also show one other interesting thing, which is you'll see this permalink here. As part of what we have offered with Pulumi, we also offer the ability to sort of look at all of what you're doing inside the Pulumi console at app.pulumi.com. And so every one of the updates that I do is actually available here, and I can see the details of those updates. So this first update I did, we can see all the different resources I created and all the details of those. And for the second update, we can see just the smaller set of updates that we made. In particular, here we added 5 and removed 4 and updated 1. Okay, but the more interesting thing is I can come over here and see my resources. And so in this case, I can see that REST API and deployment. I can also see the table and the function. And so for example, for this table, I can click on that, dive right over into my DynamoDB instance, look at the items, and see here's the counts for all the different routes associated with that. So by having this sort of project-centric view inside the resources tab here, that lets me jump immediately into those resources, it becomes really easy to get at the underlying implementation details of my application. Okay, so with that, we kind of have this application running. We've made it quite a bit simpler by moving over to this method. But one of the things, if you noticed earlier when I showed you the implementation of this code, you notice that there sort of wasn't that much logic in here, right? And even a lot of the logic that is here is kind of just plumbing. It's just deserializing things, out for figuring out what the table to connect to is, deserializing and connecting to that. Really, the only logic here is sort of in these lines right here. And so this is often the case that that the lambdas are very simple pieces of code that I'm just stitching into my infrastructure somewhere to give me access to some internal details inside my application, or that I'm using to traffic some data from whenever something gets put in this bucket. I want to also put it on this SNS topic. Any of these sorts of little pieces of sort of glue that stick my applications together. And so because this kind of pattern is so common, one of the things that we want to be able to do is, instead of you having to create this lambda manually and point at an existing application and write that application in a whole different language and a whole different tool chain, we want you to be able to actually write that just in line. And so, for instance, I can say evctx, the same signature I'd expect from a AWS Lambda, and I can just put that in line here. And so let me say undefined. And we'll see here that I actually get IntelliSense. I'm writing here the implementation of a handler for an API gateway REST API. And so I'm able to write that in line inside my Pulumi application. And this is code that's going to run when this API gets hit. So instead of me running that Lambda written in C#, I'm going to run this code that's implemented right here. But I get to write it just in line and get to have access to everything else inside my application. And so in this particular case, let me just do the simplest thing, which is to immediately return. And I can see here I actually get IntelliSense for the information I need. So in this case, I want to return a 200. And then I want my body to be some JSON. I want it to be the same thing that I saw before. And so over here we see path and count. So let's make it path. And I'll grab the event that I got passed and grab its path. And I'll put count, and for now I'll just make that always be 1. Okay, so here I just implemented a very simple instance of that same sort of thing, but directly in line inside JavaScript. So let me come over here, run Npm Run Build. And actually, let me also just do a quick thing. And I'll just log out what path I saw as well. Let me do Npm Run Build. Now do Pulumi update. Okay, so we see here we're actually going to create that new serverless function. And so here that function is just these 3 lines of code. And again, it's underneath a little component. But then I'm also going to replace some of the details of the REST API, because the REST API now needs to point to that new function instead of the old one. So I'm going to go ahead and say yes. This is going to create the new function. And it's going to update the existing REST API. And so let me try going ahead and hitting that endpoint again. Okay, I think I know. Let me actually just very temporarily, I'm going to comment this out. So I think right now there's an issue, which means we'll actually, when we try to make that update and change the function that's being called, it's not working correctly. So I'm going to just remove it and re-add it, and we'll work around that for the moment. Okay, so you see there I removed the API, and then I can just go ahead and add it back. Go ahead and say yes. Now we'll create the same function object again, as well as recreate the API that points to it. So one thing you just generally notice there is it's very easy to just make changes in my code very quickly, do a Pulumi update, and see those. And so the inner loop here for actually modifying my infrastructure, modifying my application code is actually very fast. And so here now I have this URL to my endpoint. And so let me say, we see now I have count 1 for Pulumi. Okay, that's because I hard-coded in the count 1 here. So now that I have that, I can sort of get rid of all of this code. And so that code was to embed the C# lambda, but instead I can just write it in line like this. Notice that I can also just take this function and give it a name, and so I can say, and I can also use async, so I can say async function handler. And I can also say this is going to return a serverless API gateway response. So the event is actually a serverless.request. Okay. So I'm just going to change this over to be to use the new supported node 8.10 in Lambda for using async functions. And so here I see this, and so I can just return this directly instead of using the callback. Okay. Okay, so I can give that thing a name and just pull it out like that. And so now I can just write my functions along these kind of lines. Now let me npm run build, Pulumi update. So we're actually getting rid of the old function that we no longer needed, and now let me just curl that same endpoint again. And so we see we still get 1, just like we expected. Now one other nice thing, I added that logging statement there. I could just jump over and I could come back into here and sort of say, hey, I've got my function, let me go over there. Oops. Let me refresh this. I changed the function. Let me come over to my function, come to monitoring, and view logs in CloudWatch. And so we see we've got some of the logs for this thing that are printed out, the path that got printed. So I could come and do all these clicks, but it's often much easier to just be able to do it from the command line. So if I write Pulumi logs, I can actually see all the different logs that I would have gotten through CloudWatch, but I get them pulled in here. And the other nice thing is that this will actually aggregate the logs over all the various different endpoints that I might have in my code. So in this case, I just have this one Lambda, but if I had multiple of these, I'd get all the logs right here. Okay, and so the other nice thing is then I could go ahead and use the the AWS SDK in here to make calls and to do that DynamoDB thing. For now, I will kind of skip writing the code for that just to keep things simple. But the main takeaway here is that, well, actually, I'll show just kind of a sketch of what I can do, and I'll show some other examples in just a second of this. But one of the notable things is that I have this counter table here. And so I can make a call to, imagine that I have, just write it, access the AWS SDK, and now maybe I create DB is AWS document client, and then I say DB dot update. And one of the things I need to pass to this is the table name. And so I can, instead of me having to pass an environment variable or something, I can actually just say I've got this counter table. So let me say counter table dot name dot get. And so now I can have access to any of these variables that are part of my infrastructure. So in this case, the table itself that I defined and managed along with this application inside this file. I can just use its table name directly and capture that. And so one of the nice things that Pulumi does when it takes this function code and turns it into a Lambda on your behalf is it figures out that this variable is being referenced and knows how to pull off the right details of that, the name, and embed it into the generated Lambda function for you. And so you don't have to deal with all that serialization and deserialization logic yourself. You can just use counter table like you kind of expect to. So that's a quick kind of tour of kind of how we get from the very low level working with API, Gateway, and Lambda to this much higher level ability to sort of describe just the routes that I want to handle on an API and the implementation of some code I want to handle for those routes. And so the end result is that with just a handful of lines of code here, I have kind of an example of an application that manages a DynamoDB table, AWS Lambdas, and API gateways all together. But the serverless library has support for many other kinds of capabilities as well. And so let me show you a few other examples of the sort of things we can do with the AWS serverless library. So if I come, let me first come over to AWS serverless. Okay, so this is our AWS serverless library. And if I come over here and look at the examples folder, we can see we have a handful of examples in here of some of the kinds of things we can do with the AWS serverless library. And so, for example, let's look at this topic example. So in this case, we create an AWS SNS topic, which is a AWS resource that I can use to publish to from one set of code and then consume from another piece of code. And SNS topics are a great example of a place where I might want to use Lambda because I can just subscribe to my SNS topic and say, here's some code I want to run every time something gets pushed onto that topic, instead of me having to sit there polling that SNS topic for new items. And so in this case, I have a little example, and it's doing this is something you could imagine as sort of like a web crawler or that sort of thing. Anytime I push something to this topic, I'm going to go and fetch the results of the URL that I got pushed. And so in this case, I'm going to take a look at the SNS message. So the message is the contents of that SNS message that came through. And for every one of those, I'm going to grab that URL. I'm going to do a fetch of that URL using just the normal node fetch library, and I'm going to print out an error message if it failed. Now you could imagine me doing even more things, taking the contents that I got back from that fetch and putting them into an S3 bucket or any other variety of things. But the interesting thing here is that, again, this lets me manage both the topic that I'm defining and a subscription to that topic. I could, of course, also just include a bucket, so I could say a new aws.s3.bucket. And I could say, files. And now inside here, I could just, use the AWS SDK to write into that bucket instead of just printing out an error message. And so it's very easy for me to sort of define both the infrastructure that I want to have access to, as well as the code that's going to go and operate on those things in the same file. And so being able to subscribe to a topic makes it really easy to sort of build decoupled kind of pieces of code in these sorts of examples. Of course, another really useful thing to be able to do is just is to use timers. And so in this little example here, we're using a CloudWatch timer. And so this says hourly. In this case, it's going to be rate 60 minutes is the AWS way of describing a job that runs every hour. And so every hour I want to run this code. And so again, this is a simple thing where frequently the description of what I want to do with a timer is actually a very small piece of code that really just reaches out and touches a handful of other things that are running inside my infrastructure. And so in this case, every hour I just want to publish onto an SNS topic, and then I'll handle that in some other way. And so these are very natural things to write as inline pieces of code like this, even though I could go ahead and write them as a Lambda written in Python or Go or C# or .NET or Java or anything. Oftentimes these are so small and so intertwined with the way that my infrastructure is stitched together that I actually want to do them inline like this. And so this is a very simple example of that, where I just publish that item into an SNS topic. And so then again, I can handle that SNS topic through code, and I can just print out a message every time I handle that SNS message. And so this shows sort of coordinating between two kinds of events inside one of these examples. Of course, the other one we can do is sort of buckets. And so buckets I can handle when an item is put into a bucket. Let me run some code. And in this case, every time that an item is put into the bucket, if its name is not a record file, then we will update the record file with the metadata about the last written item in the bucket. So this gives me a way to do some sort of auditing or access logging of puts into my bucket. And so you can imagine it's very easy to then just go ahead and stitch these pieces into existing infrastructure, existing serverless applications, and to really take any of the event sources that are available inside AWS and build applications which sort of react to those in natural ways. Okay, and then the final one, of course, which we just sort of spent a bit of time with, is using sort of API gateway as an event source. And so in this example, again, I'm not sure why. But in this case, we're using two kinds of handlers, both the kind of handler where we write the handler in line like this, and the kind of handler where we pass in an existing Lambda function. In this case, a Lambda function that was implemented as JavaScript. So in this case, we can have implemented as JavaScript, but put it in its own application, and that would allow us to maybe unit test this thing as a standalone piece of code instead of putting it inside my application itself. Okay, so that's a quick tour of sort of some of the capabilities in this package. Now, one of the really interesting things that we added last week was the AWS team finally added support for SQS as a Lambda event source. So if you have a queue in AWS, you're now able to handle items put into that queue using a Lambda function. That's been a feature that's been requested for pretty much since the first day that Lambda was available several years ago. And that was added just to AWS about a week and a half ago, I think. And so one of the things we did when we saw this, we said, hey, we want to have that available in this library. And so we actually added support in this library for hooking up to queues as well. And so in this case, very similar to the topic, we have a queue, visibility timeout in that queue, and we just subscribe to it. And so now we get all the events that get pushed into that queue. We will see here. And we see batch size we can specify. So we can say we expect to get things in batches of 1, or we could say up to 10 to batch up the entries that we get and to have those delivered on a more coarse-grained cadence. But then, of course, we can do whatever we want inside here, like put an object into an S3 bucket. And so this time, every time we push something into SQS, we'll see it in that bucket. And so it was really nice. We were able to light this up. AWS added the feature. We worked with the Terraform AWS provider to add support for queues as an event source to Terraform, and that allowed us to use it from the Pulumi AWS library and to light it up inside AWS Serverless. So the end result is you can now use queues as well as a serverless event source. And so along those lines, one of the examples that we added last week as part of that was this Slack message thing. And this is, we use Slack a lot here at Pulumi, like many of you probably do. So we wanted to build something which just allowed me to, every time I push to a AWS queue, SQS queue, I will post a message into Slack. And so here I have a queue, batch size 1 again, and every time a message gets posted to that queue, I'm going to look at all the records and then use the Slack client here to post a message to that queue with this message. So we can see this is the kind of message that we get from that. And so our team had fun kind of playing around with that. This gives you a sense of the kind of simple things you could do. Now I can hook this queue up to some other piece of my infrastructure. And so I can say in some other piece of my infrastructure, every time an S3 bucket gets published, I want to push something into this queue, and then I'll batch these up and send out a message about how many items got pushed. Very easy to put these little pieces of code inside my applications and get them running and deployed in a matter of just a few seconds using Pulumi. So that's kind of a quick tour. The thing, if you've watched previous videos, you've probably seen that kind of the place where some of this gets really exciting, I think, is when you combine both serverless with some of the other kind of capabilities you may be wanting to use. And so many other tools that help make serverless easier on AWS, one of the challenges they have is that they sort of really focus just on sort of lambdas and event sources, and that's what we saw kind of in some of these examples. But as soon as you want to use other features of AWS, like you want to use maybe you want to use Athena to do querying, or you want to use RDS as a data store, or you want to use containers. It's a bit harder because the abstractions can't extend into those realms as well. And one of the nice things about using just a programming language with the ability to create sort of arbitrary kinds of new components is you can make it really easy to use both some of these serverless capabilities and some of the container capabilities. And so, for example, this is one that is probably familiar if you've seen previous videos we've shown. But just to give a sense of kind of what the next level of this can look like, we can see things like here I have a bucket and I have that serverless kind of on-put event on the bucket. But inside this code, I want to actually run some container-based compute maybe as a result of this. And so in this case, I can use this FFmpeg thumbnail task, which is a cloud.task, which is a little wrapper around all the capabilities of the container service inside AWS to run a set of Dockerized code. And so in this case, it's a Docker file that's built from this particular Docker file right here. And I can just go ahead and run that. And so the ability to create a simple abstraction like this one, where just in a few lines of code I can wrap up a Docker file locally into some code that can run Dockerized inside AWS, and I can connect that into all of my existing serverless applications. And that combination of being able to do raw infrastructure, do really high-level, simple work with containers, and take advantage of all of these kind of features of really productive serverless development, I think is what the real magic is of kind of what modern application development for the cloud can look like. And so that's what we're really excited about with Pulumi. So that's kind of it for my tour of Pulumi today. If folks have any topics they want to drill in more in the coming weeks, feel free to reach out to us on Twitter or on our Slack. You can come in here and join our Slack channel from pulumi.io. Take a look at Pulumi, download it at the URL here, join the Slack and reach out to us if you have any questions, and have fun building serverless applications with Pulumi. That's it for me. I'll see you next time. Thanks a lot.